I study, but something that some of my colleagues at Johns Hopkins are looking into. So today I'll be talking about delayed discounting in relation to ADHD, and specifically some of the neuroanatomical correlates of that. So we already had some introduction to delayed discounting yesterday, but I'll just give a brief overview to make sure we're all on the same page. In general, humans and animals prefer immediate over delayed rewards. It's also the case that as a reward becomes delayed, its subjective value decreases, and this decline in the subjective value of a reward with increasing delay is referred to as delayed discounting. Delayed or temporal discounting is another term that's often used. But there's certainly important adaptive reasons for us to delay gratification. As I'm sure many of you know, being involved in research, rewards are not always very immediate, and to be successful in life in many avenues, we often need to put off that immediate desire to wait for the larger, albeit delayed reward. So delayed discounting is typically assessed by asking an individual to make a series of choices between a smaller immediate reward and a larger delayed reward. By altering the magnitude of the reward and the length of the delay, we can calculate sort of discounting function to get a sense of the extent to which an individual engages in delayed discounting. So here you can see the decline in the value of the delayed reward over time, which you can calculate an indifference point for each of these delays, which we use to determine a discount function, such as the K value, which was discussed yesterday a little bit. That assumes sort of hyperbolic shape to the discounting value of a reward. We can also use that to compute area under the curve, which I'll talk about a little bit more. So there are different ways to quantify delayed discounting, and certainly different methods of assessing it. So although we all engage in delayed discounting to some extent, there is considerable variability between individuals in discounting behavior. There's both trait and state factors that contribute to discounting behavior. More impulsive individuals tend to engage in greater discounting as a stable trait difference, but this can also be modulated by situational or contextual factors. An earlier study, which I won't be discussing today, but we published a few years ago on looking at delayed discounting in children with ADHD and the effects of schizophrenia. And we did find that stimulant medication actually reduces delayed discounting in a sample of children who tend to engage in impulsive decision making, but it can be modified, again, even by psychopharmacological manipulation. So greater delayed discounting has been demonstrated in psychiatric conditions involving impulsive behavior. We've heard of that a little bit, but substance use, addiction, and ADHD is the population that I focused on for the past several years. So several etiological models of ADHD suggest involvement of delay-related impulsivity and the behavioral symptoms that define ADHD, inattention, hyperactivity, and impulsivity, particularly in regard to the hyperactive impulsive symptoms. Neurochemical deficit models implicate altered dopamine levels as contributing to delayed discounting, either due to lower tonic dopamine or altered phasic dopamine, especially in response to cues predicting reward. Then there's brain pathway deficit models that describe alterations in frontostriatal circuitry as contributing to impairments in executive control or motivational processes, such as delayed discounting. All these models predict a strong preference for immediate reward, but the empirical evidence is actually fairly inconsistent in children with ADHD. This literature, however, is plagued by lots of variability in the tasks that are used to assess impulsive choice. It's not always a delayed discounting task. It might just be the choice between a smaller and larger reward without varying the delay, so you can't really look at how the delay is having an impact on impulsive choice. Or perhaps even characteristics of the sample. So like I said, this may be sort of more restricted to children with the hyperactive impulsive subtype or combined subtype of ADHD who are exhibiting more of the hyperactive impulsive symptoms. In addition, very few studies have examined the neural correlates of greater delay-related impulsivity in ADHD, particularly among children, although there's been some recent work on this, mostly using fMRI. The broader literature on the neural correlates of delayed discounting in healthy adults has suggested at least two distinct networks that contribute to delayed discounting. The first is a reward valuation network, which you can see in the sort of peach color there. This includes the ventral striatum or both frontal cortex, among other regions. These brain regions, as we've heard a bit already, are involved in encoding reward value. And the OFC in particular is really thought to be critical for comparing reward options to guide action selection. Then there's also a cognitive control network that's involved in, including the anterior cingulate cortex and the lateral PFC. And these control regions are really thought to be engaged during decision conflict. So when you're having to make a choice between a smaller immediate reward and a larger delayed reward that are maybe sort of closer together. So based on the identification of these two networks, it's been proposed that inter-individual differences in delayed discounting might be related to the valuation deficit, defined as sort of an inability to accurately represent the incentive value of a future or delayed reward, or a cognitive control deficit, an inability to exert top-down modulatory control over choosing that smaller immediate reward. And certainly everyone at this conference can understand it could actually be sort of an interaction between deficits in both of those networks, or alterations. So the goals of the study I'll be discussing today were to examine delayed discounting in a sample of 8 to 12-year-old children with ADHD, all combined type. We did have a few inattentive type kids, but again, we might expect to see a little bit different in that subsample, so we just restricted it to combined type, compared to typically developing children in the same age range. And given the variability in the ADHD literature, we chose to assess delayed discounting with two tasks. These tasks differ in the extent to which the participant actually experiences the delays and rewards associated with their choices. Use sort of a classic discounting task that will be familiar, that's often been used in the literature, and then a real game time task that we developed in our lab, which I'll tell you about in a little bit. And we also examined whether OFC morphology was associated with delayed discounting. We focused on the OFC for this initial approach to the data, given its involvement in reward-based decision-making and the pathophysiology of ADHD. There's certainly other regions that we plan to look at. Our sample included 106 children, 54 of which were diagnosed with ADHD combined type. The ADHD group was a little bit younger, and therefore age was included as a covariate in our analyses. Our ADHD group also had lower measures of full-scale IQ and general intellectual ability, or GAI score. This is not uncommon in an ADHD sample. We did include, or we looked at the effect of including GAI as a covariate, but we looked at it both ways, since there's some controversy in just covariating IQ in sample children with ADHD. So first I'll tell you about the classic delayed discounting task, which is more familiar in the literature. All participants completed this task, and this is one that's actually previously been used with children with ADHD in this age range. This is a screenshot of a question that's presented to a participant. During this task, they are making a series of 91 choices between a smaller immediate reward that changes, it's variable, but it ranges from 50 cents to $10.50, or receiving $10 after a delay of 1 to 90 days. An important possibly component, at least for children, that often is not done is to actually tell them that some of these rewards are real. We can't make all of them real, that we can't afford that, but they were told that some of them were real, again, in an attempt to sort of really motivate children to be thinking about their choices and making valid sort of choices, which is always a concern using these types of tasks that involve abstract choices with children. So participants were told that some of them would be real, and we chose 2 of these choices at the end of the experiment and gave them those outcomes. So if they said they wanted to wait 30 days to get a $10 gift card to Target, rather than getting that right away, or getting a $5 gift card right away, then that choice was selected, and we would mail the gift card to them 30 days from the end of the experiment. For this, an indifference point was calculated for each delay. And an indifference point can be defined in many ways and computed in many ways, but it's generally a magnitude delay combination of a larger but later reward that's of equal subjective value to a smaller but sooner reward. And that can be used then to look at area under the curve or to compute the discounting function value, the k value. Here, we took an initial approach to the data by just looking at the change in indifference points across delays using repeated measures of ANOVA to test for an effective delay, diagnosis, and their interaction. We also compared area under the curve for the two diagnostic groups. And this is a model-free measure of the degree of discounting that characterizes how much delay sort of degrades that value of the reward. So here's our results for the classic discounting task. So what you're seeing in the graph on the left is the subjective value of the reward changing as a function of delay. And children in the typically developing group are the white line on top, and children with ADHD are the green line on the bottom. And what we found here was that, as you can see, there is evidence of delay discounting in both typically developing children and our children with ADHD. This was revealed by a main effect of delay. And you can see that subjective value sort of declines over as delay increases. We also found that children with ADHD tended to prefer immediate reward regardless of delay. This resulted in a main effect of diagnosis. So that green line is sort of consistently lower. So it wasn't really changing across the delays. If it was changing, then we would have seen a diagnosis by delay interaction, such that delay differentially sort of impacts impulsive decision-making in our ADHD sample. But that was not the case. They were sort of generally preferring immediate reward on this task, and it didn't seem to be changing with delay, despite our efforts to sort of include this real reward component and sort of really engage that valid decision-making process. In addition, the other graph on the right there is showing area under the curve, which just sort of quantifies that area underneath the line for each group. And although descriptively it was lower in children with ADHD, so lower area under the curve indicates greater delay discounting, this difference was not significant. Furthermore, when I included GAI, that intellectual ability sort of measure from the WISC, as a covariate, this eliminated the main effect of diagnosis. So we didn't even see that children with ADHD tended to be more impulsive regardless of the delay there. So this pattern of results suggests that this sample of children with ADHD did not display greater delay discounting on a classic discounting task involving choices about money, although they did show an overall preference for immediate reward. So this is stuff I'm really excited about. We concluded that task to be consistent with the literature. But I've done delay discounting research for about 8 years now with children with ADHD, and I always have concerns about how they're approaching a task of that nature. So we developed in our lab a real game time discounting task. This was to determine if experiencing the delays and the rewards associated actual delays and rewards in real time, if that impacts discounting behavior in children with ADHD. So we also had participants complete this task in the same day that they did the money discounting task. This task involves an immediately consumable reward of playing a preferred game for a very short amount of time right away or for a longer time after waiting. So this is only 9 choices that were made, but it more closely parallels the animal work, where they're actually waiting for, to get their little drop of sucrose of water and then making their next choice. So they have to wait and experience the reward before making the next choice, which is important, perhaps, for discounting behavior. So our reward amounts were very small. They could play for as little as 15 seconds of the preferred game up until 45 seconds immediately versus playing for 60 seconds. Still not a whole lot of time, but it was surprising to us that some children would actually say they'd rather play for 15 seconds than wait, because a minute is just way too long. And so our delays range from 25 seconds, which is pretty short, up until 100 seconds actually, so a little over a minute. And here's just an example. Again, this wasn't actually a task that was done on the computer, but this just was a way of presenting the questions to children in a way that sort of provided some visual scale for these decisions. So they were asked, for example, here, which one would you like? You can have game time for 30 seconds right now, or wait 25 seconds and then you can play for 60 seconds. And their game was actually sitting in a clear plastic box in front of them. This harkens back to the marshmallow experiment, put the sort of thing that they want right there and make them really sweat it out. So it's sitting on the box in front of them, and they had to put it back in the box after they played and wait till making their next choice. And so yes, they were making just 9 choices. We had 1 choice for each amount of game time and each delay. So here's our results for the real game time task. We found that the ADHD group here did demonstrate greater delay discounting, as evidenced by the significant diagnosis by delay interaction with a medium effect size. Specifically, as you can see where the asterisk is on the line graph, that children with ADHD chose a smaller immediate reward significantly more frequently at the moderate delay, but they really weren't any more impulsive at the shortest delay or the longest delay. Most kids said, I can wait 25 seconds, it's not that long, but there's no way I'm waiting 100 seconds. That is just way too long for me. We also found that area under the curve tended to be reduced for the ADHD group compared to the TD group. These findings were very similar when we included general intellectual ability as a covariate. And I'm just going to skip the subjective rating because I'm running a little over here. So although children with ADHD tended to show greater delay discounting at the group level, there's variability in this preference within diagnostic groups. And this is not surprising given the heterogeneity of neurocognitive deficits associated with ADHD. But still, we wanted to sort of look within this typically developing sample, within the sample of children with ADHD, do we see that there's a neurobiological sort of substrate that is linked to this behavioral preference, regardless of the behavioral phenotype of ADHD? So this, again, was sort of a first look at the data. We focused on the OFC after obtaining a 3T MPRH on the majority of the sample. Over 90% of each group had a good quality MPRH. And we used free surfer and then applied our a frontal lobe atlas that's developed in our lab to extract several functionally distinct ROIs in the frontal lobe. And we then examined associations among OFC volume and then thickness and surface area and delay discounting within diagnostic group. And here we're looking at associations with area under the curve, one sort of value that quantifies delay discounting. So here's the results for the real game time task on which children with ADHD showed greater delay discounting at the group level, where we would expect maybe the strongest associations. And we did in fact find that children with ADHD are in green there. We did find that greater delay discounting, which here would be less area under the curve, so the bottom sort of left corner. Less area under the curve was associated with reduced OFC volume only within the ADHD group, not among TD children. Anything, the relationship in TD children was opposite, but that really didn't approach traditional level of significance. And really this association was driven by cortical surface area and not thickness, so that's what's plotted here, but it was significant for overall volume as well. For the classic discounting task, we did not see significant associations in either group, between delay discounting, that area under the curve measure, and OFC volume, surface area, or thickness. Although the relationship is in a similar direction for children with ADHD, but not significant. So to summarize and conclude, the greater delay discounting that we saw in children with ADHD was really limited to the real game time task, which might suggest that impulsive decision making is strongest in children with ADHD when they're actually experiencing the rewards and delays associated with their choices in real time. The association among delay discounting on the real game time task with OFC surface area was also only observed in the ADHD group. Again, we have to look at other regions of the brain, but this might suggest that evaluation deficit contributes to delay discounting in children with ADHD. And interestingly, this relationship was only observed on the real game time task, suggesting that other brain regions could be involved in decision making in the classic discounting task, which involves more abstract sort of decisions, possibly involving more, anterior cingulate or dorsolateral prefrontal cortex. And finally, OFC morphology was unrelated to delay discounting in the TD group on either task, again suggesting perhaps involvement of other regions. So we have some work to do on looking at other regions in these networks that are involved in delay discounting. And I just want to acknowledge our lab, in particular my mentor, Stuart Kosofsky, the imaging staff who holds my hand through all of this, as neuroimaging research is fairly new to me, and also the Keri Center for Brain Imaging and our funding sources. And thank you all for your attention.
That Johannes Decker come on down and get set up for his talk, and while you're doing that, we'll allow Keri to answer a few questions.
Hi, So I thought that was really interesting and very clever paradigm to make delayed discounting really real. But I'm curious, you had a bullet point on one of your slides saying that you were like controlling for the overall number of trials or the overall time or something.
Yeah, I think it's a very technical sort of issue, but in the animal literature, it's important that you include a delay after the reward is delivered, so the time actual trial length is consistent between choices, which controls for sort of the rate of reinforcement. You can imagine if you chose immediate reward every time, you're then getting rewarded much more quickly if there wasn't a delay built in after it. Most people find that when you include this with humans, they don't discount anymore. So I was very happy that we still saw that. Children with ADHD did discount with that ITI sort of built in that controls for the overall trial length. Is that what you're asking?
Yeah, so I guess I'm curious then, if you control for overall trial length, then it sort of seems like if you're more impulsive, then you're shifting your weighting to be after you get to play the game. Right? So you get a short period to play for a little while, but then you have to wait a really long time for the next trial, versus you're waiting a long time for a longer reward.
Yes, so you have to wait on both ends. So it's actually, what we see is that some of the, seem to be smarter kids say, well, I have to wait anyway, so why don't I just, say I'm going to wait on the front end, and it's only 9 choices that they're making, so it takes them a little while to, I think, you can figure that out for the task. But some of the work by Cindy LaBarca has actually showed that in children with ADHD is sort of specific, and you look at amygdala reactivity, and it's about that waiting period before making the choice. That's really sort of anomalous in children with ADHD. That's where they have this heightened reactivity. So it didn't seem to affect their decision making. I wouldn't expect that to make them more impulsive than anything in the class.
Great, thank you.
Were the children on the ADHD group medicated?
No, they discontinued medication at least the day prior to and day of observation. And our sample, I believe it was about 60% were regular ADHD.